All right, all right. Welcome to class, everyone. So I think we can start now. Mr. Opeyemi, please confirm if you can hear me.
Yes, please, I can hear you.
Okay, sir, you have the floor.
All right, thank you very much. Mic check. Let me know if you can hear me, please.
Loud and clear, sir.
All right. So let me just go ahead and share my screen and let me know once you can see my screen. So can we all
Yes,
see
we
my
can
screen?
see your screen now.
All right, great. So first, apologies also once again for having this class this week. We're supposed to have this class last week, but because of reasons beyond my control. So here we are today. So I believe okay, yeah, they said the recordings will be shared, but for the sake of those that were not in that first class, the first class we started out with what data analytics is, as well as Power Query for data transformation, and that's going to be where we'll continue today. So I would implore you once the recording is available today or tomorrow, please go through that recording as well as today's session also. So for today, we're going through three major things. So we have a lot of things to cover today. I will finish up with Power Query today. I'll start out with what, let me open my slide, with the second aspect of Power BI, which is called data modeling. And I will also introduce us to what is called data analytics expression, also known as DAX. Then we'll start a little bit of introduction into data visualization ahead of our last class in terms of the training, because I believe the challenge is already out. The data set we'll be working with is already out. And the goal of this training is to prepare us to be able to attempt that challenge, to be able to build a portfolio for ourselves. So which is why everything we'll be doing for this training, if you're able to painstakingly go through all the resources and follow through, you shouldn't have any problem attempting the challenge at all. So let's just dive into it without further ado, because 1 hour will almost be here now. So the first class we explained what Power Query is, just as an introduction, and I said Power Query is basically used for data transformation. It helps you to connect to whatever data sources you want to connect to do your data transformation. So now this is my Power BI interface. If I want to get data, I already showed us how to get data last week. But one of the type of data we'll be getting this week would be, what if I have data sets? Let me open an example for us. What if I have different data sets that I want to join? An example is this. I have a folder that contains a data set, maybe a data set of 1997, another data set of 1998. And I want to consolidate them together. So I'll show us two different examples because your data set can come in different range so that you can be aware. So let's say I have this particular folder, this particular folder called transaction. And this transaction folder, I have two different data sets. They have the same structure. Let me open it, 1997, 1998. Let me open it so we can get to see what it looks like. All right. We should all have access to these data sets from the classroom. So now this is the 1998 data set, transaction date, stock date, product ID, customer ID, store ID, and that. And we also see the same thing for 1997. We see that everything, they all have the same column. The only thing that just changing is the transaction date. So that's as we have multiple sheets like that in a particular folder. And we want to consolidate everything into one master data. How do we do that in Power BI to help us do that? So all we just need to do is we'll go to our get data. From our get data, since our data that I want to consolidate, all the data is in a particular folder. So I will just connect Power BI into that particular folder. So I'll go, I think this was the one I was opening. So I'll locate more. Wait for Power BI to open more data sources for me. Now we see folder. So I'll click on that. I'll click connect. So all I need to do is to navigate to the folder that contains the data I want to connect to. So I'll just navigate into it. Mine is on the desktop. I have my Power BI data set and my data set, and I have a folder called transaction. And I'll click OK, just to allow Power BI to connect to that folder and import the data I need into my Power BI. So now by doing that, Power BI let me see that, oh, guy, I have two data sets. These are all the different, this is the content of data set. This is the name of the file. These are all the different, what is called metadata about those data. But first, let me go, I can easily just do combine here, combine and transform data. But before I do that, let me just go on and transform the data first. And it opened up the Power Query editor for us. Now, I'm sure this is not the first time we're seeing it for those that were available in the first class, because we also went through how to transform data with Power Query. And I even gave us an assignment. So in case you've not done the assignment, go and attempt the assignment and upload, probably send to me via email so I can check. And I'm sure if you actually did the assignment correctly, you should be able to know that you've done the assignment correctly without me having to review it for you. So I won't have to go through all different things about Power Query again. We did that in the first class. So what I just need to do is in this data, the only thing I need is the content. Now I'm trying to explain, if you have a folder that has multiple data sets that you want to combine, how do you go about it? So all I just need to do is to do what? This is the only thing I need. I need just the content. I don't need any other metadata. I don't need the name. I don't need the extension, the date of access, the date it was last modified, and all the other metadata. So how do I do that? I just right click on this column. I don't want to remove this column. I want to remove other column. So I click on that. And what do you see? You automatically move the other column. Now, if I want to now combine it, how do I combine it? So I just hover around this. If you hover around this, you can see combine files. So I'll go ahead and click on combine files, and I'll allow Power Query to do its internal transformation to help me to do what? To combine the data. So here we go. So Power BI has let me see that, oh, this is basically what I have. I have the table, I have the transaction. So just to explain the difference between this and this, even though they are the same thing. The data, the one that has this table with a blue icon, even though they are the same thing. But the one that had the blue icon, the blue knob that we have here is basically referencing the table in that Excel worksheet. Whereas this is just the Excel worksheet, the worksheet itself. So, and that's why it's that this is not well transformed, which is why most of the time it's better you work with the table inside it. So we'll just click on the first one and we'll click OK. So wait for Power Query to combine the data for us. Okay, so now Power Query has done the transformation for us. It has combined the data for us. But how do we know that Power Query has combined it? Now, first of all, last week I explained that once you have your data, you want to check that there are no error and there are no empty. And currently, I can see that everything is 100% across all the column. In case you don't know how to activate this symbol that you're having here, all you just need to do is go to your View tab and click on Column Quality. So if I check column quality, I'm able to see the quality of my column. So I can see that, okay, fine, the first column has 100% valid, there's no error, there's no empty, which is supposed to be ideal. Once you see that everything that you have is fine, the next thing you want to check is data type. Data type basically means that you want to ensure that if a field is a date, you want to make sure that everything in that field is a date. If a field is a number, you want to ensure that everything is a number. So how do you do that? Just click on this symbol that you have here. So currently this is supposed to be a date, not a text. So I'll click on this symbol and I'll change it to date. I'll do the same thing also. My stock date is supposed to be a date. I'll change the data type. Product ID, I can leave it as O number. Customer ID too, I can leave it as O number. What do I have? My store ID, I can leave that too as O number. And my quantity, since I'll perform mathematical operation on, I may want to know the total quantity or anything, so I'll leave it as decimal. Now, just to check if our data combine well, let's extract the year out of this column. Let's extract the year out. If we want to extract the year, let's go to our add column. Under our add column, we can see there is a date section. I right click on my date and I just want to extract the year. And that has done that for us. So let's check how many years we have here to be sure if our data actually combine. Let's see. So we see that clearly we now have the 2 years, 1997, 1998. I don't know, we have more than 3 data sets that will combine together, maybe 1999, 2000, we'll also have that here. So that means our data now is well transformed. So that's one of the things you can use Power Query for. You can use Power Query to do your data. It's basically used for data transformation. Connect to your data source, perform whatever transformation you want to do. And once you have that, you can now go ahead and say, oh, you want to start building your report off. So that's basically going to be more or less like a touch point on Power Query. Now I would employ you to go over the recordings for the first class where I go in depth into how to use Power Query, all different interfaces of Power Query for data transformation. And if you're able to also go through the assignment, I'm sure you shouldn't have any issue, because the data you'll be working with for the challenge, you will need to do some form of transformation. And your ability to use Power Query well would make your work seamless. So which is why I'm trying to emphasize the importance of why you need to be able to know how to transform your data to the way that you want it. Now, having explained that, and let me go back to the slide we're working with. So the next thing we want to do is what is called data modeling. And before I explain what data modeling basically is, let's just go ahead to import all the main data sets we would use to build a simple project. So I'll go ahead and if I show us data set, so we have a transaction, which we already combined. Transaction has multiple data, so we combined it already. So we want to import our customer data, we want to import our product data, we want to import our region data. And we also want to import what is called returns. So return basically means in the supermarkets, people could buy a product and say they return it. Maybe it's not good or they don't want it again. So this particular supermarket has a data for returns. So we also want to keep that because we might be interested in knowing which particular product do people return more in terms of return ratio. So we might be interested in knowing, checking that particular insight. So we want to import these returns also. We also want to import our store. Maybe there's a particular store where most people used to return stuff, right? So let's just import all the particular data set. And to be able to import that, Power Query can help us to do that. So I can just click on new source and navigate to the CSV file. So I'll gradually import all of them. I'll import my customer table. So click OK. So what do I need to do? Rename this as customer. I can also rename this capital transactions. So what are the transformation I need to do on this data? The first thing I need to use first row as the header. I'm sure we're probably familiar with already. So I do that. Then let's check our data type for number, account number. Can leave that as first name is the text, last name is the text, customer address text. Let's check. What else? I think we're fine in terms of our data type. Okay. Total number, can leave this as whole number, this as whole number. Opening dates, the dates. What else? So I think we're good. So let's import other table. So import our product table. Okay. All right. So products. So also let's do our transformation. Use first row as header. This to our O number. We're good with this. What else? Retail price is decimal. product cost. Now, this might look a bit like boring, but trust me, you are saving yourself a whole lot of stress downstream when you start building your reports. So you want to ensure that you are working with the right data type. So what else? Low fat, that, I think that's all. So let's import other ones. So returns. Let's call this returns. Special headers. This is the dates. Product ID, O number. Let's just use all our IDs as O number. Product quantity, the XML. I think that's all. What else? Let's see the next thing to import. So a store. Store. Let's change this. Call this. O number. I think we're good. Okay, dates. All right. Now the last thing. Now we'll explain later when I get to data modeling. But for now, let's import our calendar lookup or calendar table. Even though most of the time, not all of the time, you won't always have a table called date. So you have to be the one to create it. Now, when I get to what data modeling is, I will explain why you need to have what is called a date table or a calendar table in your data model. It's very, very important. When I get to data modeling, I will explain. But for now, since we already have a table that helps us, that basically tell us all the different dates. So let's just import that. So we have, let's call this a dates table. I can either create this by ourselves in Power Query or create it in Power BI with DAX. So I'll get to DAX. I'll explain how we can create a date table because it's very, very important you have a date table in your data model. Now that we've created all of this, let's just convert this to dates and maybe extract some important field. Extract year, extract month, extract quarter, and maybe the last one. What else can we extract? I think let's just leave that. So now that we have that, so I've imported all the different data that we need. So now let's now go to, like, we can easily do that for any data. So if you have any data you want to analyze, an example is the challenge you want to work on, the first thing you would do is what? Import the data. And before you import the data, you want to have what is called data understanding. You want to understand the data you're working with. What are the things that I have in data sets? What are the things we're trying to achieve? Because you don't just dive into a data project and start working. You need to have a good understanding of the end goal, what you want to achieve. And secondly, you want to have an understanding of the data you're working with. Now, this is a sales data set. You want to probably just build a report for a supermarket to understand the status, to get some insight out of the sales report. And we've imported all the data sets that are available. So that would be the first thing you want to do. All the data sets that are available, what are the data sets that I have available? Are they okay? Do I need to join data sets together? But there are instances where you would need to join data sets. Maybe by next week, we'll download the challenge, then we'll go through it together and just give you some insight on how to join all the data together to now start making sense out of it, to start building your report. But you need to have a good understanding of the data you're working with. And that will be dependent on your understanding of the problem you want to solve. So once you know, okay, fine, this is the problem I want to solve, And these are all the data that are currently available for me to solve that problem. So now that I want to build a sales report, and these are all the data sets that we have available based on understanding. Transaction table basically hosts all the daily transaction. Who bought the product? When was the product bought? Where did he buy the product in terms of store? The customer that bought the product that was bought, and so on, the quantity of the product that was bought, and so on and so forth. The customer table basically gives us all the information the supermarket have about their customer. So customer one, this is the account number of the customer, this is the name of the customer, and so on and so forth. Is the customer married or not, and so on and so forth. So these are all the information that we have about the customer. The product table just gives us, all the products they have in that supermarket, all the information about the product. I've talked about returns. So that means some products were returned at some point in time. So we have, say, for a particular date, this product was returned from this particular store, and this was the quantity that was returned. And lastly, we have a store table. The store table basically gives us what? Information about all the different stores the supermarket have. So say an example like supermarkets, a ShopRite. ShopRite can have multiple stores across the country, right? So that means store ID number 1 can be for Lagos. Store ID number 2 can be for Abuja, and so on and so forth. So those are the information that we have. Now, this last one, even though we imported it ourselves, most of the time you will not be given. You won't have a date table. You'll be the one to create your date table yourself. And why is that important? Let's now go to the second agenda for today, which is data modeling. Let me open my slide. Now, what does data modeling mean? Now, data modeling is one of the most important aspects of building a Power BI report. And I can even tell you the concept of data modeling is also very, very important when you start doing for those that will be going into data engineering. Now, what does data modeling mean? It basically means all your tables that you have, how do they relate to each other? So currently, if I go to my Power BI report, I want to ask myself the question, how does my store table relate to my product table? How does my product table relate to my customer table? Or how does my customer table relate to my transaction table? So in answering that question, what you are basically doing is what is called data modeling. So you want to ensure your data is properly modeled, because if your data is not properly modeled, it will affect the performance of your report. And most importantly, it will give you wrong results. So that's why you'll be getting wrong results and you won't be able to understand why am I getting wrong results. So most of the time, your wrong result can just be as a result of your data not properly modeled. I can tell you it's very, very important that you take ample time to understand how your data relate to each other. Once you have a good understanding of how your data relate to each other, you can now build a relationship out of it, and it will make your report and analytics seamlessly. I'm sure you've already seen that visualization is almost like the last thing you do. So when you get the data, you don't just dive into building reports or analyzing data. All of this process has to be in place. So having understood that, yes, data modeling is very key, which is also called relationship between tables. Now, what are the relationships that you can have between tables? Now, there are basically two types of relationships I can have between tables. Let's go back to our data. So this is what I'm going to do. Let's assume I've loaded this data already. I've transformed it already. Now we're done with Power Query. Let's close and apply so that we can now come back to our Power BI interface. Right. Let's wait for it to load. Okay, it's almost there. Such a big data. All right, good. So we're good. Now, during the first class, I explained to us that this field region would contain all the data set that you load. Now, during the first class, because we've not loaded any data, we didn't see anything. So now you can see that all the data that we've transformed in Power Query that we loaded is now appearing under your field ribbon. And last week also, during the first class, I also explained that you have your reports view, which basically this is where you build all your reports, your canvas. You have your data view. So here you can now start seeing all the different data that you have. So you have a date, you have a product, as you can see it, you have our returns, you have our store, and you have our transaction. Now, the third one is where we'll be dwelling today. The third one is called model, where you will be building what is called data model. And what does data model means? I already explained. Data model basically answer the question, how do my table relate to each other? And in order for me to understand how my table relate to each other, there are two concepts that you need to have a good understanding of. The concept of dimension tables and fact tables. Now, what does dimension table means, or what does fact table means? Now, dimension table are basically tables or data that you have that describe your data. They give what is called description about your data. Now, what do I mean by description? They answer the question, what, who, when, and maybe how. But most of the time, they answer the question. In this context now, we're talking about supermarket data sets. So our dimension table would be what? Who bought the product? That means we're talking about customer data. We're talking about what did they buy? That means we're talking about the actual product that was bought. Where did they buy it? Probably we're talking about what? The store it was bought. Maybe when was it bought? We're talking about when? The time. So those type of data that answers, that give you a description about your data sets are called dimension table, or they are called dimensions. Now, why do you need them, basically? Why do you need dimension? Because most of the time when you have your data set, let's go to our transaction data. So our transaction data tells us that, oh, we have, for this particular date, this particular store, this particular product was bought. Product what? Product ID 14. Now, this product ID 14 has a name. If I want to build a report and say, oh, on the 23rd of October 1998, so product was bought. If I want to present it to my stakeholder, I won't tell them product ID 14 was bought. I have to give them the name of that particular product. Now, that means this product ID that is 14 has a name. And where can I get that information from? That means I have to get the information from product table. If I go and check my product table, product ID number 14, let's assume I want to filter, just to filter. So that, check. So we have that. Sorry. I don't know, I can't see. I can't see the lower part of, give me some time. Right. Right, okay. So now we clearly see that, oh, product ID 14 is actually JFAS. So that means I can easily just tell my stakeholder that, oh, on the 23rd of October, JFAS product was purchased. Who purchased it? There's a customer ID. That means I want to get information about this particular customer, I have to go where? Go to the customer table. That relationship is what is called data modeling, because there's a relationship between this table and those other tables. Now, in another way to also identify your dimension table is you would always have unique information. You can never have duplicates, because your customer table, a perfect scenario now, in a bank, financial institution would have what is called a unique information that uniquely identify every customer. So in the customer table for a bank, two customers can never have the same ID. So that customer table for a bank will be their what? Their dimension table, because you know that table can never have duplicates. So your dimension table would never have duplicates. Your product table can never, two products can never have the same product ID. Even if they have 100, no matter the number of product that they have, they would always have a unique ID to identify them. So that's one way for you to identify a dimension table. The first thing is your dimension table would always answer the question. They describe your data. They give you a descriptive information about your table. Your fact table, on the other hand, what does your fact table give you? Your fact table basically give you facts from the word, literally, about your data set. Let's go to our transaction. So they let us know that, oh, this is the quantity of product that was sold. That means for a bank now, transaction or sales, transaction for a bank will be the fact table, because in a day, multiple people would have different form of transaction. So your fact table would definitely bound to have duplicates, because the same customer can purchase stuff multiple times. Me as a customer now, I've used the bank today multiple times. So, and that's why your fact table is bound to have duplicates. Your dimension table can never have duplicate. So another way to identify your dimension, your fact table, if you want to identify your fact table, is one, your fact table will contain the fact about the business. What was the revenue, the sales amounts, the whatever the metric. In this instance now, the fact we are looking at is quantity. So that means on a particular date, this was the quantity that was bought. On a particular date, this was the quantity that was bought. All right. Your dimension, on the other hand, will not give you that fact. Your dimension table will only give you what? It will only give you a descriptive information about your data set. So you know that, oh, the store ID number 1, this is the region the store is. This is the name of that store. This is the store name. This is street. It will give you a good description about that particular table. So in case you see different data sets, because nobody will tell you when you say any data set, this is the fact table. This is the dimension table. You are expected, based on your understanding of the data, to be able to understand that, oh, from the structure of the data set, this one is a fact table. This one is the dimension table. How do you know which one is fact? How do you know which one is dimension? From your dimension, it gives you information about the what is descriptive information about your data set. What, when, where, and maybe when. And that's where the when comes in, the date comes in. So in case, which is often the scenario, you will not always be provided with your date. You have to be the one to create that date dimension. Remember I said, even though I imported this, but most of the time, you have to create the date dimension yourself, because you want to answer the question, when was it bought, or when am I looking at? Many of the time, you always have your where, depending on the context. We're talking about supermarket data set now, so which is why you have your when, what did they buy, where was it bought, and so on. Depending on whatever context you are talking of. If you are talking about a financial data set now, a financial data set, say a bank would have who made whatever transaction is. So that means they have your name, you know that you made the transaction. When was the transaction made? That's date, dimension. Maybe which POS, if it's a POS transaction, which terminal was that POS? Basically, they will have all the different IDs for different POS, right? So which channel, if it's a mobile or internet, that becomes a dimension. So depending on the context, your dimension would always answer the question: what did you buy, when, where, and maybe when. So once you are able to streamline that data set, break it down. If it's for you to list out all the data set that you have, open a notebook, open your Google Doc, note it, list out all the data set that you have. Once you list out the data set that you have, based on understanding of the content of the data set and the problem you want to solve, you now start asking yourself, which one is the dimension, which one is the fact, which one is dimension, which one is the fact. Because once you have a good understanding of that, it will now help you to know how to model your data set. Now, having explained that your dimension would always have unique, can never have duplicates, whereas your fact table is bound to have duplicates because your fact table just gives you fact about the business. That means the same customer can purchase a product multiple times. The same product can be purchased multiple times by different customers. So it is bound, you are bound to have duplicates in your fact table. Now, how can I explain that? Now, since I already explained that now, if I want to build my report, I need to be able to get the name of this product out. I need to be able to get the name of this customer out, right? But currently in this my data set, my transaction data, now we already know that my transaction data will be my facts table because my transaction data has multiple, it has duplicates, and not only that, it's also the table that contains the fact about my data set, the fact which is the quantity that was purchased per time. So this is the fact in the data set. So it will become my facts table. And not only that, now contain other information about that fact. I can see that, oh, product ID 14 purchased it, customer ID 1814, store ID 19. Now, I currently don't know anything about all of this. These are just ID. If I want to build my report, I should be able to find a way so that even though I am seeing product ID 14, I should be able to get the name out. Even though I'm seeing customer ID 1814, I should be able to get the customer name that has this ID. Even though I'm seeing store ID 191919, I should be able to get the name of the store. And in order to do that, I have to now create what is called relationship between all the tables. How are all the tables related? An example is from our transaction table, I see that there's a product ID. How is my transaction table related to my product table? How is my transaction table related to my store table? How is my transaction table related to my returns table? And so on and so forth. And in order to build relationship, there are two concepts you need to understand very well. It's a concept of what is called primary key and foreign key. Now, what does primary key means? Now, I know I'm explaining to you, but it's very, very, very important you have a good understanding. Now, what does primary key means? Primary key basically means is a unique identifier in a particular table. So, what is the ID that uniquely identify a table? That is called the primary key in that table. Let's go to our product, our customer. Let's open each of them. Now, which ID will which field will uniquely identify each customer? I think we already have it. It's called customer ID. Two customers can have the same name. So, and that's why name can never be a primary key because it's normal. You can have two customers who have the same name, the same last name, the same second name, most likely. They can be living in the same address, even in the same city, but a field that would uniquely identify each customer will be what customer ID. And that's why for those that will be doing database administration or data engineering, you want to create, this field may not exist in some instances. You might want to be the one to create that unique ID by yourself. So what do I mean? Let's assume, let's go back to our data set so I can explain. Let's go back to Power Query. To go back to Power Query, you just click on this. Oh, sorry, this is supposed to. So I click on this to go back to Power Query. So now let's assume I have this. Now my data set currently has a unique ID. But let's assume this field is not there. Let me remove it. Right? Now, as part of my, I know I want to have a unique ID. Now I could create, even though whatever I'm doing, I have to find a way to also manipulate it and create it here. But the data set is already well prepared. But let's assume I don't have any unique ID in this data set. And I know I need a unique ID. I could create an index, a unique ID. So if I click on add column, there's an index column here that I say either start from 0 or 1. So if I click on this, what do you see? It automatically creates a unique incremental number for me. So I know that, oh, so this is me automatically creating this unique ID. Now, not only am I creating it, I need to now find a way to relate it to my fact table, which is transaction. But because this table is fine already, it has our customer table already has that unique ID and how it is related to our transaction table. So we don't need to create that. I'm just letting you to know in case you want to create a primary key. You could either create it using just create an incremental index column and find a way to map it to the subsequent data that you need. So I just have to explain that in case you come across such type of data. Okay, so now having explained that, so I'll explain that primary key means it is unique in that table. It basically uniquely identifies every record in that table. You can never have duplicates, and that's why your primary key will always exist in your dimension table. So if I go to my dimension table, what are the dimension table I have? If I go to my customer table, so let's go to our data. If I go to my customer table, our primary key in this table will be what? Customer ID. So my customer ID here will be unique. So this 425 I have here, no other person would have this ID 425. So it is unique. If I go to my product table, no two products will have this ID number 4. So it is unique. Now let's now go to the second concept. Second concept, which is called foreign key. Now what does foreign key means? Foreign key basically relates, is an identifier in your fact table that relates the corresponding dimension table. Now what do I mean? It means that in your fact table, which is why I say it is very important, you must be able to identify which one is fact, which one is dimension. Because once you have a good understanding of which one is fact, which one is dimension, every other thing will build on it. Having explained that and having understood that our transaction table is our fact table. Now, each of the field, each of the unique ID that we have there will now be related to their corresponding dimension table. What do I mean? Now, this product ID 14, right? Even though we can have multiple instances, it is bound to be duplicates. This same product 14 can be bought multiple times, so right? So you can always have duplicates in your fact table because a product can be bought multiple times. The same customer can purchase a particular product multiple times in a particular day. So you can have multiple times. As you can see, multiple products were purchased from the same store, 1919, which is bound to happen. So each of these ID is called a foreign key to their corresponding dimension where they are the primary key. So it's bound to say a foreign key in a table is a primary key in another table. So foreign key would always relate to primary key. So in this table now, product ID is a foreign key in this table because it relates to the product ID in the product table, where the product ID in the product table is a primary key, but the product ID in the transaction table is a foreign key. So that means if I want to relate these two together, if I want to relate my transaction data to my product data, I can only relate them together using this ID here called product ID. So two tables can only relate to each other if they only have those references. If the foreign key in that fact table has a corresponding primary key in the corresponding dimension table. So that means you can't join two tables together if they don't have that reference, that relationship. So which is why this is just a side note, which is why one of the tests data engineers will do is what is called reference. You want to check reference integrity. What does reference integrity mean? You want to confirm that in your fact table, all the foreign key that you have actually have a corresponding primary key because you don't want your pipeline to break. As an example, it's possible that this product ID 77 that we have in our fact table, it's possible that this product ID 77 does not exist in the product table. So if that does not exist, you want to determine what should happen so that whatever your report or whatever thing you are building that is dependent on that data, you can manage it properly. So That is why one of the tests you often do, and that may not concern you, I just have to mention that in passing. So you only join two tables together using that relationship of primary key and foreign key. How does primary key in one table is unique, but foreign key in another table is, you have duplicate of it. But the foreign key in one table would always reference the primary key in another table in the corresponding dimension table. So I don't know if anyone have any question before I proceed. Any question from anyone before I proceed? Question from anyone? Okay. So in the answer to another question, now that we've understood what that relationship, now let's now build a relationship across our table. So to build a relationship across our table, all we just simply need to do, now we don't need to do anything serious. Now, even though by default, Power BI will try, Power BI will try to create relationship for us. Now, all of these are basically relationship, but sometimes Power BI could make an error in terms of relationship. So you want to double check the relationship that Power BI is creating. So now let's just rearrange. So you can rearrange all your tables. Now there are different types of relationship or different types of data model that you can build. There's what is called the star schema. There's what is called the snowflake schema. There's what is called the OBT. There are a lot of them. For the sake of performance, which general adoption often recommend building a star schema, right? Now, what does star schema mean? It basically means you want to build a star such that, and you know how a star means, you would have, in terms of rearrangements, you have your fact table at the center and all your dimension table will surround it. That's really what star schema means. So now let's locate our fact table. Now we established that our fact table is what? Our transaction table. So this is it. So our fact table is our transaction table. So we can go ahead and delete all of this relationship. We'll create that by ourselves. Let's delete everything. We'll create it by ourselves. Delete this. This. What else? All right, so let's now build our relationship ourselves. So this is our what? So we already know that this is our fact table. Our transaction table is our fact table. So that's what is going to be in the center. And every other thing will be around it. So this is our product table, is the dimension. Our date is the dimension. Our customer table is also a dimension. Which table is this? Okay, our store is also a dimension. So I think let me zoom so I can see it clearly. So our store is also a dimension. Now there's one more thing, there's one more table, which is a returns table. Now who can tell me, if we go to our returns table, is a returns table a fact table or a dimension table? Drop it in the chat box. Based on all the explanation I've given, and just looking at this data set, is a returns table a fact or a dimension table? Let me see your response in the chat box. Based on what I've explained, what do you think returns table will be? Right, fact table. Right, that's 100% correct. So clearly we can see it's a fact table. There are many ways you can easily know it's a fact table. It contains foreign key, it contains ID that will reference different ID from our dimension table, 100%. So clearly we can easily see it because I'm seeing product ID, which already lets me know that, oh, if I want to relate this returns table to my product table, I will have to use this product ID. So that means this product ID in this returns table becomes the foreign key because there's only one primary key in one table. And this product ID in my product table is the primary key. So that means clearly I see that my returns table is a fact table. So we are correct. So now having understood that, so that means I can just put two of them side by side. So that means a returns table, our returns table is a what? A fact table. So now let's now build relationship. How do we build relationship? You will connect. Is anyone dropping in? Yeah. So all you just need to do is for all the tables, your fact and dimension, you connect the foreign key from your fact table to the dimension to the primary key in your dimension. So let's start doing that one by one. So for my product table, I'll connect my product ID to, just drag it to my product ID. So doing that, let's wait. So now a relationship has been created. Now we'll explain what this one and star means. But let's just say a relationship has been created. So there's already a relationship I've created between product and transaction. What else? Again, my store table. So store and region. Where are our regions table? Our region should be somewhere. Do we not load region? Oh, we already have everything. Oh, let's see. I don't think we loaded. I brought in region. Okay, we don't have region. So let's quickly bring in, let's go to Power Query and bring in our region. Yeah, so there's a regions table. So let's see. So it's first rollers, headers. So we have that. Change it to phone number. I think that's all we need. So let's close and apply. Okay, so let's go back to our data model. Now we have our regions table. So you see that Power BI have tried to create a relationship for us. So let's see if the relationship is correct. Just once you click on it and you hover around it, you'll be able to know if the relationship. So there's a relationship between store and region. So that means there's a relationship between region and store. Okay. Let us rearrange that. Okay. So now store ID. So just click on stock ID related to our store ID here. So we have that. So now, even though there's no relationship between regions and transaction, but there's no region ID, but by virtue of the fact that there's a relationship between store and transaction, right? That means, and there's a relationship between region and store, that means there's an indirect relationship between region and transaction. So it flows down, it can easily flow down as we say it. So that means I can interact, I can create a relationship, I can build reports that will probably show the region where I had the highest sales because there's an indirect relationship between my region and transaction. So let's join every other thing. So my customer ID, customer. So what else? Date to, now there are two dates. So I have transaction dates. The focus. Why is this not dragging? Okay. Transaction date. And we can also transaction date. Now this is a fact table, which we've established already. So can also relate the date here to the date here. And can also do the same thing for products. So we can. So maybe let's bring this here. So product ID, product, and what else? Store. So lastly, store ID, store. All right. So let's bring this here and let's bring this here. So those are our two facts table. So now let's explain one more last thing on the data modeling. Now, what does this one and star means? Now, one and star basically means that in our dimension table, there's only one instance. So it flows from one to many. That means for my regions table, there can only be, there's only one instance of region ID. So that means you can have duplicates. So that means there's only one instance of region ID in my regions table, but you would have multiple instances of a particular region ID in my store table. So let's relate, say, store table and transaction. So you have one instance of store ID, because definitely you can't have duplicate of store ID in a store table, but you'll have one instance in a store table, but that same store ID can have duplicate, multiple instances in a transaction table. And that's what this star means. So that means you have one to many. So you can have many relationships. You can have one-to-one, many to one-to-one, one-to-many, as the case may be, depending on the type of data set you are currently working with. You can also have one-to-one, as the case may be. So now we pretty much have everything we need for our analysis. So the last thing I want to do in terms of our modeling is all of our primary key in our dimension, we're going to hide everything because we want to have access to it. So I'll hide this. To hide, just for you to click on that hide. So I've hidden that. So my store also, I'll hide this. All those IG, all those ID, I would hide this also, because I don't want to have access to it. I'll have my customer ID and product ID. All right. Now, just let us see why data modeling is very key. I want to show us a good example. Now, everything we've done here now, we are done with our data model. Our data, we've created a relationship among all our tables, and we can now start building our report. But now let's see why is data modeling very important. Let's do something. Let's assume I delete the relationship that exists between the product table and transaction. Let me delete it. So we can see clearly why data modeling is very key. Now I've deleted that relationship. Now let's go and create a report. Let's assume we want to create a simple report that, excuse me. Now to create any report, these are called your visualization pane, as I explained, right? So let's assume I just drag one of the bar chart. I want a normal bar chart. Let's drag this. So just if I click on it, so I have that. And I went to my product table. I selected the maybe product brand, right? I have all the product brand there. And I want the quantity. So I click on the quantity. Then let me use a table so we can easily see it. It will be much easier to see. I click on table. Let me make it big. So we're already building small reports, but we'll go more into reporting next week. So for my product table, I say I want the product name. And for my transaction table, I say I want the quantity. Now, what do we see? We see that for each of the products, it's basically telling us that everything is what? 839. Let me expand this so we can see it clearly. So what do we see? It's telling us that all the product brands have the same name, which is wrong. So that's telling the total quantity for ADG is this, total quantity for this is this. Now, why is that the case? Because there's no relationship between product brand and quantity. Power BI is unable to help you to compute what is the total quantity for this particular product brand. So it just go ahead and just give you the total quantity for everything. and give you as though that's the value. But now let's see what will happen when we create a relationship. Let's come back here. So create a relationship between product ID and we'll just drag it here. And let's see what will happen now. By just a single step. Now, by creating our relationship now, what do you see? Automatically, Power BI is able to go under the hood, help you to compute the total quantity for this particular product and return it for you. This particular product and return it for you. So if your data model is not well done, trust me, your reporting will have a lot of issues, which is why you often want to spend time. Yes, visualization is very interesting and what you want to quickly dive into, but you want to spend enough time to first understand your data. After understanding your data, you want to spend enough time transforming and cleaning the data well, which is what we've done with Power Query. Now, once your data is well transformed, you now want to properly create data model by asking yourself, how are my table related together so that I can link that relationship together? Once you're able to do that, trust me, your analysis and reporting will become seamless. All you just need to do is write the right data expression, which is called DAX, and you need to do that expression for you, and you are good to go. I see we are exactly 1 hour, so that we don't overshoot our time. It's already 6:10. I don't know if anyone have any questions. So next week, which is like last hour, we'll just go straight into data analysis expression, introduction to DAX, and we'll start building our report. Just to give a bit of context on what we're going to do. You have access to this file already, so you can also play with that. So from next week, we'll start what data visualization is, and then we'll build this sample dashboard we are going to create. And to create that sample dashboard, this is data set we are working on, which is data set we'll build our data model on, is what we've done already. Then we'll now start explaining what does it mean by DAX, which is what we'll also explain next week. What does DAX mean? How do you create simple DAX to start creating all your report? Trust me, the easiest part of the job is reporting. It's just for you to click on whatever chart you're interested in, drag the field you're interested in, use your colors, and so on and so on. But one of the most important part is how do you model your data? Is your data well transformed? And for the data visualization aspect of it, yes, we'll tell you some best practices, how to tell a story, and of those things, but which we'll cover next week when we dive into our data visualization and reporting proper. Any question from anyone?
Hello, good evening.
Wow. This has been another amazing session. Thank you so much, Mr. Opeyemi. My wonderful coordinator, please let's appreciate Mr. Opeyemi in the chat room. Let's appreciate him. Thank you so much for taking your time to do this for us, sir. So yes. I'll be going through the chat room. If I can just pick 1 or 2 questions.
Okay.
So just come through. Okay, so someone is asking, what if our data set has just 1 table? Is there a need for modeling?
Okay, no, like I said, data modeling is basically creating relationship between multiple tables. So if it's just 1 data you are working with, there's no need for, the only thing you just do is transform your data. And once your data is okay, continue to build your report. So data modeling is basically creating relationship between tables.
Okay, sir, thank you so much. So that's the answer. So I think the other question I have here is if we are going to have the recording of this session. Yes, the recording will be uploaded in the Google Classroom. So before I end the call, let me just share my screen to introduce us to a very important thing. Please confirm if you can see my screen.
Yes,
please confirm if you can see my screen.
Yeah, I can see your screen.
Okay, great. So this is the AI Financial Inclusion webpage, the project webpage. So we have all the things we need to know about this particular project participation program. So the important thing is that the data set for this project is now live. So we can all go to this webpage. I'll be dropping the link in the chat room. So it's very important that we go to this web page and download this data set and start visualizing our data. So the submission date is also here, which is scheduled to be on Friday, 8th of April, 2022. So it's very close. So it is very important that we'll start applying the knowledge we've been learning in this program. We'll start putting it into use. If you have any issue at all, just put your complaint in the Google Classroom. Our facilitator is right there to help us out, and we also have the DSN team on standby. If you have a question, just drop it there. So the link, I've dropped the link in the chat room. So just access the link and you can see all the details you need. If you're having any issue, like I said, just put it in the Google Classroom. We're going to pick it right up and answer your question. Ladies and gentlemen, thank you so much for joining us again this evening. This will be the end of the session for today. Yes, the engagement continues in the Google Classroom as usual. So we'll be expecting the engagement to continue there. Thank you so much for joining us this evening. Do enjoy the rest of your day.
All right,
bye everyone. Yeah.